Dr. Snell's law tells us that this ratio is constant and is equal to the refractive index of medium 2 with respect to medium 1. And it is also equal to the ratio of speed of light in medium 1 to the speed of light in medium 2. And that is the same as the ratio of the absolute refractive index of medium 2 to the absolute refractive index of medium 1.
The light ray passes from denser medium to rarer medium. The angle of refraction is 90 degrees. The corresponding angle of incidence in the denser medium is called as critical angle, total internal reflection. When the light ray traveling from denser medium, if the angle of incidence is greater than the critical angle, then the light ray doesn't enter into the rarer medium and reflects back into denser medium. This phenomenon is called as total internal reflection.
The layer at the bottom is more warmer, but as you go up it gradually keeps on becoming cooler and cooler. Now the light from the sun hits the object. The tree there is the object. After hitting the object, the light will reflect and it will enter the first layer. Now the first layer is denser. Now as and when the light is going from denser to rarer, it will keep on bending away from the normal. So at each layer what you see is the light is bending away from the normal. But at one point, what you will notice is light will hit at an angle which is greater than critical angle. And at that point, instead of light undergoing refraction, the light will undergo total internal reflection and enter my eye. Now once it enters my eye, human eye always perceives that light always travels in a straight line. So now I can see the reflection there at the bottom.
Optical fiber cable is made up of thousands of fiber strands, and a single fiber strand is as thin as a human hair. Optical fibers carry information in the form of light. In this experiment, light passes through a prism. You can see that at the interface, the light gets bent instead of going straight. This phenomenon is known as refraction. Refraction occurs when light passes from a medium with one refractive index to one with another refractive index. The light bends towards the interface when it goes from a medium of high to one of low refractive indices. Refraction is the reason why a pencil looks bent in a glass of water. This simple refraction technique is effectively used in optical fibers. Now, let's make this experiment a hypothetical one. Using some dopants, we are able to increase the refractive index of the glass in real time. As we increase the refractive index, the light will bend more and more towards the surface. After a time, you can see that the light will pass through the surface of the glass. If we increase the refractive index further, the light will suddenly come back to the first medium as a pure reflection. This is called total internal reflection. The total internal reflection is possible if we increase the incident angle rather than increasing the refractive index. In this case, at a certain angle called the critical angle. The light will come back to the first medium. If the laser strikes the interface at an angle greater than the critical angle, total internal reflection will happen, and the light will reach the other end.
A medium in which speed of light is less and refracted ray bends towards normal when light passes from one medium to another is called optically denser medium. A medium in which speed of light is more and refracted ray bends away from normal when light passes from one medium to another is called optically rarer medium.